Chapter 8, Section 7, Factoring Special Cases. If you remember talking about the special cases when we were multiplying, there were a whole bunch of rules that we talked about how kind of shortcuts on how you wouldn't have to use the table method, FOIL method, or the distributive property to multiply two binomials. But to factor special cases with the exception of one, I am just going to say to use the same processes we have used in the last two lessons. So find your factors of C or AC, depending on the type of trinomial that you're given, and then make sure that they have a sum of B and factor it that way. An example of this says, what is the factored form of x squared minus 4x plus 4? Notice in this case, I have an understood 1 in front of my x squared, so all I need to do is find my factors of 4 that have a sum of negative 4. Well, there's two ways to have a product that is positive. I can either multiply a negative times a negative or a positive times a positive. But if you look at your B, I have a negative 4x. So I know that I need to be multiplying a negative times a negative. Factors of a positive 4 that would have a sum of negative 4 are going to be negative 2 and negative 2. Negative 2 times negative 2 is a positive 4. Negative 2 plus negative 2 is a negative 4. So I know my two factors are going to be negative 2 and negative 2, so I can rewrite this trinomial as the product of the binomials x minus 2 times x minus 2. Well, anytime you're multiplying something, including a binomial by itself, in this case I have x minus 2 times itself, x minus 2, we can write it as that factor squared. So what I'm going to be able to do is I'm going to be able to write this as the binomial x minus 2 in parentheses, and then I need to square the whole thing. Go ahead and check your answer to make sure that when I multiply x minus 2 times x minus 2, I get the trinomial x squared minus 4x plus 4. When you multiply your first terms, x times x is x squared. Your outside terms, x times negative 2x is negative 2x. X times negative 2 is negative 2x, sorry. Your inside terms, negative 2 times a positive x is a negative 2x. And then your last terms, negative 2 times negative 2 is a positive 4. Negative 2x minus 2x is a negative 4x. When I combine my like terms, I get x squared minus 4x plus 4, which is the trinomial that I needed to end up with. Factoring a difference of two squares. For all real numbers a and b, if you have the binomial a squared minus b squared, it's going to factor into the product of the binomial a plus b times a minus b. Examples of this, it says, what is the factored form of x squared minus 64? Notice I do have a difference because I am subtracting x squared minus 64. What would you square to get x squared, or what's the square root of x squared? So your a is going to be x. Your b is going to be 8 because 8 times 8 is 64. This one's really nice because now that I know my a and my b, I can literally just write the two binomials, x plus 8 and then times x minus 8. You do still need to go ahead and check your answer. To check your answer, you could multiply your first terms, x times x is x squared. Your outside terms, negative 8 times x is negative 8x. Your inside terms, 8 times x is positive 8x. And then your last terms, 8 times negative 8 is negative 64. Negative 8x plus 8x cancel each other out, so you're left with x squared minus 64. One thing that I do want to point out here is that you could use the other method that we've used to factor. In this case, and in these cases when we're talking about the difference of two squares, you could actually rewrite this as x squared plus 0x minus 64. So if you rewrite it like that, it's going to have the same value as x squared minus 64, but it just says that your b would be 0. Well, what two numbers multiply together to give you negative 64 but have a sum of 0, and your answer would be 8 and negative 8. And notice those are the two factors that we've used to write our binomials. This next example says, what is the factored form of 9x squared minus 25? What would you square to get 9x squared would be 3x. So 3x is going to be your A. And then what squared is 25? And the answer to that would be 5. So we can use these two terms, A equals 3x and B equals 5, to write the two binomials 3x plus 5 and 3x minus 5. Go ahead and check your work. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. 5 times 3x is positive 15x. And 5 times negative 5 is negative 25. Negative 15x plus 15x is 0, so we're left with just 9x squared minus 25. Factoring a difference of two squares when you have to find the GCF first. When you can factor out a greatest common factor from a polynomial, you do that first, and sometimes the remaining expression will be a difference of two squares. So if we look at the example, what is the factored form of 12x squared minus 3? Notice this is a difference of two terms question. However, 12x squared and 3 are not perfect squares. But if you look at 12x squared and 3, they would have a greatest common factor of 3. So first, we want to factor out a 3, and when we do that, we're left with 3 times 4x squared minus 1. Well, now 4x squared is a perfect square, and the square root would be 2x, and 1 is a perfect square, which would be 1. So what I can do now, I'm not going to be able to get rid of my 3 that I factored out, but I will be able to keep it outside and write 4x squared minus 1 as the two binomials 2x plus 1 and 2x minus 1. To check this problem, I'm going to go ahead and I'm going to bring down my 3, and then I'm going to factor my two binomials. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 1 times 2x is a positive 2x, and then 1 times negative 1 is negative 1. Your negative 2x plus 2x are going to cancel out, which would leave you with 3 times 4x squared minus 1 in parentheses. What I need to do now is go ahead and distribute your 3. 3 times 4x squared is 12x squared, and then 3 times negative 1 is negative 3. That is the binomial that I needed to get when multiplying my factored form. The last example says 98n squared minus 200. Well, 98n squared and 200 neither one of those are perfect squares. But they can be factored by 2. 2 can be factored out of both of these. So the first thing I need to do is factor out a 2, which leaves me with 2 times 49x squared, and I don't know why I used x, it should be n squared, minus 100. Well, 49x squared is a perfect square, and 100 is a perfect square. The square root of 49x squared would be 7x. The square root of 100 would be 10. So I can rewrite this as 2 times 7x plus 10 times 7x minus 10. Just like in the last example, I'm going to check my answer. The first thing I'm going to do is just bring down my 2 and go ahead and factor my two binomials. 7x times 7x is 49x squared. 7x times negative 10 is negative 70x. 10 times a positive 7x is positive 70x. And then 10 times negative 10 is negative 100. Well, negative 70x plus 70x are going to cancel out, and you're going to be left with 49x squared minus 100. And now I need to multiply by both of those terms by 2, and when I do so, I get 98x squared minus 200, which is what I needed my factored form to multiply out to give me.